Now this is again a speed against time graph. It's different from the earlier one, and let's see what's the difference. Now here, if you notice, the body is moving with an increasing speed. So let us try and find out what is the speed at 3 seconds. To find out at 3 seconds, we have to know where is 3 seconds. Here is 3 seconds. To find the speed, we go up to the graph here, and then we find out the velocity. So we go to the velocity graph, and here is the velocity. It is 30 meter per second. So the speed at this is 30 meter per second. Then we'll find out at 7 seconds next. So to find out at 7 seconds, we need to go to 7 seconds first. This is 7 seconds. We'll do it in another color. So we go to the graph here, right up here, 7 seconds. So from the graph now, we go to the velocity axis, and that is at this point. So at 7 seconds, we see it is 70 meter per second. It is increasing. At 3 seconds was 30, and at 7 seconds it has become 70. Now we'll go to see at 0 seconds what is happening. Now where is 0 seconds? It's right here at the origin. And what is the velocity at that? Look at the velocity graph, speed graph. It is 0. So at 0 second in the beginning, it is 0 meter per second. Now let's look up to see at 10 seconds. So first at 10 seconds, where is 10 seconds? Here is 10 seconds. So from 10 seconds, we go up to the graph. Here 10 seconds will go right up to the graph here. Here we come here, and then we go up to the velocity, and this we see is 100. This is 100 here. So this will be now 100 meter per second. So in this, the body is increasing its velocity. So this body is increasing the velocity. Velocity is not constant. Velocity increases velocity. If there is change in velocity, there is acceleration. Fine. Then, and we can also find the acceleration in each of the cases. So this body is not uniform motion. This is non-uniform motion. Why non-uniform motion? Because it does not cover equal distances in equal intervals of time. The body is going faster and faster. In the first second, in fact, it covers 10 meters, and in the second it covers much more. Third second, it covers even more, and it goes faster and faster. So non-uniform motion. Now from the same graph, let us learn to find the acceleration. We already have, we know that this is the graph of a body with changing velocity. The velocity keeps changing and increasing. So if the velocity is increasing or changing, there is acceleration. Let us find the acceleration in the first 5 seconds. Now what is the formula for acceleration? We know A equal to V minus U over T, where V is the final velocity, U is the initial velocity, and T is the time taken to change the velocity. So for the first 5 seconds, we need to know what is the velocity at 0 seconds. Velocity at 0 second, that would be our U initial, and then we need to know what is the velocity. So to velocity at 0 seconds, velocity at 5 seconds. To find velocity at 0 second, let's go to 0 here. This is 0. This is time 0. And what's the velocity there? We've seen it is 0 seconds. So here velocity at 0 is 0, and you know initial velocity is called U. And the velocity at 5 seconds, where is 5 seconds? Here is 5 seconds. So if we want to know velocity at 5 seconds, we have to go up here and then go to the velocity graph here. This is the velocity at 5 seconds, and we see the velocity at 5 seconds is 50 meter per second, which is v. So in this sum now, your u initial velocity, this is the u initial, which is 0 meter per second, and your final is at this point. This is the final velocity, which is the v, and that is 50 meter per second. And your time taken for this change is here. This is the time taken between 0 second and 5 second. So the time taken here is 5. So when you want to calculate your acceleration, you have to know your u, you have to know your v, and you need to know your t. So from the graph we see that the u is 0 meter per second, the v is 50 meter per second, and the time is 5 seconds. So we got all our information. Let's put it in our v minus u over t. So a is 50 minus 0 over 5, and that is a is 50 over 5, and that is 10 meter per second square. So that is the acceleration between the first 5 seconds. 10 meter per second square is the acceleration. Now for the same graph, let's find the acceleration between 3 seconds and 9 seconds. So same procedure, let's mark for 3 seconds. Where is 3 seconds? Here. And this is 9 seconds. We need to find between this. So again, for acceleration, we need 3 things. We need to find the initial velocity, the final velocity, and the time taken for this change. Now to find u, you know u is at 3 seconds. So at 3 seconds, I have to find the velocity. I go up here and I go to the velocity graph. So this point here is my u, this point, and that works. The u is 30 meter per second. So I'll write here u 30 meter per second. Now my final velocity is at 9 seconds. So I marked 9. So I have to go up to the graph to find the velocity at 9 seconds. So this is the graph. Then I go up here. This is my point at 9 seconds here. So this velocity here at 9 seconds, which is v, final velocity is 90 meter per second. So I'll write the final velocity 90 meter per second. So have you seen the velocity has changed from 30 meter per second right up to 90 meter. Now, how long has this change taken? It took from 3 seconds to 9 seconds. So this will give me my time. This is my time. And my time in this case is 9 minus 3. It took 6 seconds for this change to take place. So the time is 9 seconds minus 3 seconds. It has taken 6 seconds for this change to take place. So acceleration, v minus u over t. So acceleration, we saw v is 90, your u is 30. Here see 90 and 30 over your time is 6. So the acceleration here is 60 over 6, 10 meter per second square. This acceleration also is the same. Have you seen? 10 meter per second square. If you recollect, last time we had learned the acceleration between 0 and 5, and that acceleration was 10 meter per second square. Now this acceleration between 3 and 9 is also 10 meter per second square. It is the same. So this is a body undergoing uniform acceleration. So this body is, the velocity is changing, but the acceleration is uniform. It is same. Increasing velocity but uniform acceleration, because the acceleration is remaining the same. So this is how you calculate acceleration from the velocity time graph. You just have to find out your u and your v, initial and the final velocity, and the time taken for it. So in general, now I have a velocity time graph and I want to find acceleration. I always have to mark my initial point here. Say this is my initial point here. This is my A, and I need to find my final point. Say this is my final point here, and I call that as B. And if you have noticed here, this difference, this part will give my difference. This will give V minus U, and this area will give you my time. I mean, this line will give my time. This is a difference in time. This will be difference in time here. This is be the difference in time, and this will be my difference in velocity. So this gives increase in velocity or the difference in velocity. That is V minus U, and this line here gives me my difference in time, which I call T, and then I do A equal to V minus U over T. So basically my A is this part divided by this red line. Difference in velocity here, difference in velocity over difference in time. This will give my acceleration. Now in the same graph earlier we learned to find the acceleration. Now we will learn how to find the distance covered. Here we need to find the distance covered in the first 6 seconds. So let's mark the first 6 seconds. So here from 0 to 6, this is, we need to find distance covered in this from 0 to 6. So we do the same process. We go up to this graph here, and this area will be the distance covered. In this case it is a triangle. So this area will give us distance. Fine. So let's mark this area. Say this is called OAB. So area of triangle OAB is equal to distance, numerically equal to the distance covered. Now how to find area of OAB? Now we know it is a triangle, and the formula for triangle is half base into height. So we have to look out for the base and height of this triangle. So look up here, you will agree that this is the base here, this is the base of the triangle, this here base, which we know is 6 units. So we write here 6 units, and the height in this case will be this, right? This will be its height, the height of the triangle. And you know how much is the height? It is 60. See, from here to here, it is going to be 60. So the height is 60. So if you cancel this now, you will reduce this half 6 into 60. So I do this 3. So this is 180 here, okay, unit square, because I'm finding area, it is square. So but the distance will also be, distance will be 180 meter. So this answer is 180 meter, the distance covered in the first 60 seconds. Now we'll go also and find out what is the distance covered in just 4 seconds. Now to find distance covered in 4 seconds, we do same procedure from 0 to 4. So this is our 0 second here, and 4 second will be here. So we got to find the area now. You will have this point. So this area, we'll put it in another color this time. This area will give us for 4 seconds. So this area will be equal to the distance. Now again, to find this area, it will be half base into height. So half, where is the base? This is the base. Between 1 and 4 seconds is the base. So the base is 4 units. That's the base. And the height here, this is the height. And this height will be 40 units. 40 units. So the area now will be 4, which is the base, into the height, which is 40 units. So you will agree that this is going to be now 80 meter. So the distance covered in the first 4 seconds is 80 meter. So here we can say distance is 80 meter, equal to distance covered in the first 4 seconds. So that is 80 meter. So in this lesson you've learned 2 things from the velocity time graph. If you have here the velocity time graph, you can find here in the velocity time graph, you can find acceleration by finding u and finding v and finding the time. And in the same velocity time graph, here it is velocity time graph, you can also find area. By finding the area, you can find the distance. The area gives us the distance. And the slope, this is called the slope. This against this gives us the acceleration.